College Trigonometry, Chapter 9, Section 3, Further Identities. And we're just going to go through some more identities that we're going to be using. Now, again, we're not really going to be verifying identities. We're going to be doing more application type things. The first identities we have are double number identities. For example, the cosine of 2a. Now, that would be the cosine of a plus a, which if we use the sum formula, we get cosine a minus sine a, which gives us cosine squared of a minus sine squared of a. And some other forms for cosine of 2a can be obtained by substituting either cosine squared of a equals 1 minus sine squared or sine squared equals 1 minus cosine squared. So we actually have three different forms for the cosine of 2a, and you just use whichever one is most convenient or that you have the information for. These are our double number identities. We're not going to derive them all. You see we have three of them for cosine, and again, which you use is completely up to you. If you only know the cosine, then you're going to want to use the 2 cosine squared of a minus 1. If you only know the sine, you're going to want the other one. It's really up to you which one you use. For sine of 2a, we only have one identity, and for tangent, we only have one. That the cosine is 3/5 and the sine is negative. Find the sine of 2 theta, the cosine of 2 theta, and the tangent of 2 theta. So you're going to use this information. If you know the cosine, you can use a right triangle to find the sine and to find the tangent to help you with this. Pause the recording, give it a try, and then resume when you're ready to check your answer. Okay, so to find the sine of 2 theta, we need to find the sine first. We know that cosine squared plus sine squared is 1, so we can use this, or again, you could use a right triangle, a Pythagorean theorem to find it. Either way will work. It does tell us that the sine is negative, so we need to put that the sine is negative 4/5, and once we know that, then we can just use the formula, and we get that the sine of 2 times the angle is negative 24/25. And here we can use the other expressions as well. We've got the formula for cosine of 2 theta, and they chose one to use. And then you see for tangent of 2 theta. And two different ways of finding that. Since we know the sine of 2 theta and the cosine of 2 theta, we can just use the fact that tangent is sine over cosine, or we can use the actual formula itself. Okay, let's try another one. Simplify each expression. Okay, this time we're kind of working backwards. This time we have the right side of the identity. We want the left side. Pause the recording, give it a try, and resume to check your answer. So we know the cosine of 2a is cosine squared minus sine squared. So if a is replaced by 7x, then 2a must be 14x. So cosine squared of 7x minus sine squared of 7x is the cosine of 14x. And we're going to do the same with the sine. The sine of 2a is 2 times the sine a cosine a. So this is going to be the sine of 30, but it's going to be over 2. It's going to be 1/2 the sine of 30. And we can actually solve that. We know the sine of 30. The sine of 30 is 1/2, so we get 1/4. We also have some product-to-sum identities. These can be used in calculus to help find integrals of functions that are products of trigonometric functions. If you take AP calculus, you'll be doing that. If you take the survey of calculus, you really don't get into the trigonometric functions in calculus. And then adding identities, this is kind of how we get them. If we add the identities for the cosine of a plus b and the cosine of a minus b, we get 2 cosine a cosine b. So solving for cosine a cosine b, we get the identity that the cosine of a times the cosine of b is 1/2 cosine of a plus b plus cosine of a minus b. And similarly, subtracting and adding the sum and difference identities for sine and cosine, we can derive the identities that you see here. So these are our product-to-sum identities. It's when we have the sines multiplied, the sine of one angle times the sine of another, the cosine of one times the cosine of another, or even mixed up. And these are the identities that we have for those. These are their equivalents using sums and differences. Okay, so you're going to rewrite cosine 2 theta sine theta as either the sum or difference of two functions. Okay, so go back to the table or go to your formula sheet, decide what you need to use, and put it together. Pause the recording, give it a try, and resume to check your answer. Okay, so we're going to use the identity for cosine A times sine A. 2 theta will be A and theta will be B. So substituting that in, we get what you have here, and our final answer is 1/2 sine of 3 theta minus 1/2 sine of theta. We can get another group of identities that are used to rewrite the sums of trigonometric functions as products. And here are our sum-to-product rules. We're not going to take the time to derive those. Basically, you're just solving the previous ones and rearranging them. And fortunately, again, these are on your formula sheet, so you do not have to memorize these, but you do need to know when it is appropriate to use them and how to use them. So we're going to write sine of 2t minus sine of 4t as a product of two functions. Pause the recording, give this a try, and resume to check your answer. Okay, so we're going to use the identity for sine of A minus sine of B. A is going to be replaced by 2t and B by 4t. And there we go, putting it all into the formula. And simplifying, we get 2 cosine 3t times sine of negative t. Then we're going to use our negative number identity, which is one of those that you should know. The sine of a negative angle is the same as the negative of the sine of that angle. So the negative comes out front, and we have negative 2 cosine 3t sine t. And half-number identities. These are used in calculus when eliminating an xy term from an equation in the form you see here. So the type of conic it represents can be determined. And from the alternative forms of the identity of cosine 2a, we can derive 3 additional identities. Anyway, here are half-number identities. The symbol plus or minus indicates that the sign is chosen based on the function under consideration and the quadrant of the angle divided by 2. So the cosine of A over 2, you see that in the sine, the tangent. We actually have 3 forms for the tangent. Exact value of the cosine of pi over 12. Now you may think, well, how am I going to find the exact value? We don't have a pi over 12 on the unit circle. It's not a special angle. Well, that's true. However, pi over 12 is pi over 6 divided by 2. So what we're going to do is we're going to find the cosine of pi over 6 over 2 using our half-angle identities. So pause the recording and use that identity, and then resume to check your answer. Okay, so we're finding the cosine of pi over 6 divided by 2, putting everything in, and then substituting in the actual value for the cosine of square root of 3 over 2. This looks really complicated. We simplify it as much as we can. We don't really want any double-decker fractions, and it's kind of weird because we've got a square root under the square root, but that's fine. We just leave it that way. All right, given that the cosine of x is 2/3, and this is going to be in the fourth quadrant, find the cosine of x over 2, sine of x over 2, and tangent of x over 2. Okay, again, you're going to use those half-angle identities. Pause the recording, give it a try, resume to check your answer. Okay, so the original angle is in quadrant 4, which means the half angles themselves are in quadrant 2, and that's going to govern the signs that we have. So these are going to end up in quadrant 2, which means our sign will be positive and everything else is going to end up being negative. And once we know that, we just put the information into the formula. And notice our sign is positive. Everything else we put a negative in front of. And let's try another one. Let's simplify this expression. Now this time, we're kind of working backwards. We have the right side of the identity. We want to figure out what would have been on the left. So pause the recording, look over your identities, figure out which one this matches to. Resume the recording to check your answer. Okay, this matches up to the cosine of an angle over 2. So a is going to be replaced by 12x. So we have the cosine of 12x over 2, which is the cosine of 6x. Okay, the rest of this recording is additional practice. So if you will pause the recording as you try these, resume to check your answer, and continue in this manner to the end of the recording.